In this video, we are going to learn how to solve problems involving lens formula under refraction of light. Okay, we learn how to apply lens formula on questions involving refraction of light, and also learn to calculate problems involving power of lens. So in short, to stay to the very end of this video, because we're going to learn a lot. I'm going to be simplifying a lot of things here. Okay, so having known that, let's go into the details of the video. So let's begin with these questions I have here and progress from there. So question 1 says an object placed 2 cm in front of a converging lens of focal length 10 cm produces a magnified image 8 cm high. Determine A, the position of the image, B, the size of the image. Okay, now note that it's either you call it converging lens or convex lens. The two terms mean the same thing. Okay, so for this question, let's first of all bring out a parameter. So for this question, we have, first of all, let's take note of lens formula. All right, now note that for a converging lens or a convex lens, the focal length is usually positive. All right, whereas for a diverging lens or concave lens, the focal length is usually negative. Okay, so in this question, converging lens is involved. That means our focal length will be positive. So the mirror formula will be 1 over f equals 1 over v plus 1 over u, where our f is focal length, our v is image distance, and our u is the object distance. So in this question, we have it says an object placed 2 cm in front of a converging lens. So our u is 2 cm. Okay, whereas our focal length f is 10 cm. We also have, okay, produces a magnified image 8 cm high. So we have our image height hi to be 8 cm. Okay, we have to determine the position of the image and the size of the object. So to begin with, to get the position of the image, we are looking for the image distance. That's the position is unknown. So let's substitute the values we have here for u, object distance, and focal length respectively in this lens formula. So you're going to have 1 over our f is 10 equals 1 over v plus 1 over our u is 2. Alright, so we want to make v the surface formula. So this 1 over 2 will cross over the equality side, change the negative. So we're going to have it to be, let me clean this part. Okay, so it's going to be 1 over 10 minus 1 over 2 equals 1 over v. So you find their LCM. So the LCM will be 10v. Okay, so 10 into 10v will give us v. Alright, minus 2 into 10v will give us 5v equals, so v into 10v will give us 10. So at this juncture, you neglect this denominator. So we're going to have v minus 5v, we're going to have it to be minus 4v equals 10. Okay, so you divide both sides by -4 to make v the subject formula. So this will cancel this. So when 2 cancel this one, I'm going to have it to be 2. When 2 cancel this one, I'm going to have it to 5. So 5 over 2 we give, remember we have negative sign here. So 5 over minus 5 over 2 is the same thing as minus 2.5. Alright, so this will be the image distance v equals minus 2.5. Okay, so let me clean this part. Okay, so we now have our v to be minus 2.5. So this is negative value. That means the position of the image is a position, this image is a virtual image, since a negative value. Okay, Had it been we got it to be a positive value, it would have been a real image. Okay, now to find the size of the object, we're going to apply this formula for it. We're going to apply hi, as image height over object height, equals image distance over object distance. So when you substitute the values, it's going to give us, remember we have our image height to be 8 over, so we don't have the object height. The object height is what we're looking for, the size of the object, so is unknown. Let's use x to represent it, equals, okay, so the image distance is down minus 2.5. Well, this time around, you're not going to represent the minus in this expression. Okay, the minus there shows that the image is virtual, so we're going to use 2.5 over, then the object distance is 2. Alright, this 2 here. So when you cross multiply, you're going to have, let me write below. Okay, so you're going to have 8 times 2 will give us 16. Okay, equals 2.5 times, you're going to have 2.5x. Okay, so you divide both sides by 2.5, so it's going to give us 2.5. Okay, so this we cancel this, so we're now left with 16 divided by 2.5. Let me punch it. Okay, so it's going to give us 6.4 cm. That would be the object height. Okay, so that's it for question 1. Let's wipe everything and solve question 2. Okay, so for question 2, it says determine the nature and position of the image of object 2 cm from a diverging length of focal length 10 cm. Okay, so for this question, we have a diverging length. Well, that means our focal length will be negative. So the middle formula will be 1 over minus f equals 1 over u plus 1 over v. Okay, so in this question, we have the image distance. Okay, we don't have the image distance. We have the object distance to be 2 cm. Okay, we have the focal length f to be 10 cm. This is 10. So let's substitute this value in the formula. So when you do it, you're going to have, so 1 over, because of it's a diverging length, we are going to apply the minus sign now. Minus 10, okay, equals 1 over 2 plus 1 over v. So to make v the solid formula, this 1 over 2 will cross over the equality sign and it will change to negative. So we're going to have 1 over minus 10, okay, minus 1 over 2 equals 1 over v. Alright, so this is what we're going to have. Now, in mathematics, it's not proper for a negative sign to be at the denominator. So this minus sign under 10 will go up to this one. So this whole expression will now be minus 1 over 10, okay, minus 1 over 2 equals 1 over v. Okay, so you get the LCM. When you get the LCM, you're going to have, let me represent it here. So LCM of 10 to v will give us 10v. So 10 into 10v will give us v. So v times negative 1 give us negative v. Alright, minus 2 into 10v will give us 5v. 5v times 1 will give us 5v equals v into 10v will give us 10. 10 times 1 equals 10. Okay, so at this juncture you're going to have minus, let me clean the up. Okay, so you're going to have minus v minus 5 will give us minus 6v equals 10. To make v the solid formula, divide both sides by minus 6. Okay, so our v will be 10 divided by minus 6, so it will give us minus 1.666. Let's leave it at 3 decimal places because we keep having 6. Okay, so we have it to be cm. This will be the image distance. So from this question, the position of the image is this value, and the nature is a virtual image since it's a negative value, so is a virtual image. So that's it for question 2. Let's wipe this now and solve further problems on this so that we can understand it better, and also we can help to solve problems involving power lens. Okay, let's wipe this. Okay, so let's look at this question 3. So question 3 says an object 1 cm high is placed 18 cm from a converging lens, forms a real image 2 cm high. Calculate the focal length of the lens. Okay, so as usual in this problem, let's bring out the parameters. So we have the object height, that's our HO is 1 cm, and we have the object distance U to be 18 cm. We have the image height, that's 2 cm, image 2 cm high, that's our H I to be 2 cm. Okay, so we don't have the image distance B is unknown. So to find the focal length, we are going to apply this formula. Since it's converging lens, the focal length will be positive, so the lens formula will be 1 over f, the focal length equals 1 over u plus 1 over v. In this expression formula, we don't have our image distance, so we have to get the image distance first before we use this formula to find focal length. Okay, so to get the image distance, we're going to apply this formula: hi, image height, over object height equals image distance over object distance u equals, so when you impute the value, you're going to have the image height is 2 over object height is 1 equals the image distance v over object distance u is what, 18. So you cross multiply. When you cross multiply, you're going to have 18 times 2. Therefore, our v will be 36 cm. Okay, so now that we have 36 cm, let's substitute everything in this expression, both u and v. Let me wipe this side. Okay, so we now have our image distance to be 36 cm. So when you put it in the lens formula, you're going to have 1 over f equals 1 over our u is 18 plus 1 over 36. So we find the LCM. So LCM will give us 36f. So f into 36f, we're going to have it to be 36 equals 18 to 36f, we're going to have it to be 2f. Okay, plus 36 into 36f, we're going to have it to be f. Okay, so we're going to have 36, okay, equals 32f plus equals 3f. So to get the focal length, divide both sides by 3. So therefore, our focal length 36 divided 3 is going to give us 12 cm. And that will be the focal length. Okay, now let's solve question 4. Let's write everything here. Okay, so question 4 says determine the focal length of lens with power plus 5 diopters. Okay, now to get the power of a lens, this is a formula that is applied or that is used to get power of lens. So we have the power of lens P equals 100 over focal length measured in centimeter cm. Okay, so in this question we have the question 4, we have the power of length to be 5. Okay, equals 100 over f. So to get the vocal length, it cross multiply. So we're going to have 5f equals 100. Divide both sides by 5. So the vocal length will be 100 divided by 5 is going to give us 20 cm. Okay, so that's it for the vocal length for question 4. And for question 5, let's solve question 5 this side. So question 5 says determine the power of length of a concave lens with vocal length 25 cm. So we have the vocal length to be 25 cm. But remember, this is a concave lens, and a concave lens or a diverging lens usually has a negative vocal length. Alright, so it's going to be, when you impute or express it in the formula we have here, so you're going to have the power P will be 100 over minus 25 because of the nature of the lens is a diverging lens or a concave lens. So when you simplify for this, will give us the power will be 100 divided by minus 25 going to give us minus 4 diopters. Alright, so this will be the power of this lens. Okay, so that's basically you can solve problems involving lens formula under refraction of light in physics, and also find the power of lens in light under physics. Hope there's something interesting for this video. Now note that convex lens or converging lens is used to correct someone that has myopia or short-sightedness as a defect, whereas a concave lens or diverging lens is used to correct someone that has hypermetropia or long-sightedness as an eye defect. Okay, so that's it for this slide, guys. Hope you learned something interesting. If you are new to the channel, be sure to hit the subscribe button now to subscribe to the channel for more videos like this. So like, share, and comment on this video. Tell me how you feel for what you learned from this class. If you seem to have any specific questions to ask, feel free to leave your question in the comment section below, and I will be sure to give you a response. That's it for this class, guys. Thanks for watching. See you in my subsequent video.